All right, so go ahead and once you get your sheet of paper, I need for you to go ahead and make sure that you put this in as number 31 in your binder. I have gone ahead and I have filled that in the top corner for you, so you know that there should be number 31 in your binder. All right, so what we are going to do today is you are going to watch this video and you are going to fill in your notes accordingly. So I will go ahead and give directions about when to pause the video, and you will go ahead and make sure that you get all the information down. So we've been talking about scatter plots, and like we discussed yesterday, a scatter plot is it's a graph that has a bunch of different points plotted on it that show a relationship. Now, sometimes this relationship appears to be linear because occasionally all of these dots, when plotted on a graph, create sort of a line direction. Remember that we are looking at all the points together and not individual points when we look at a scatter plot. Well, sometimes when my scatter plot is making a linear formation, I can create a line of best fit. A line of best fit is a straight line that represents the data on the scatter plot. So we have multiple different points plotted on the scatter plot, but our line of best fit is one single line that sort of shows us the direction the scatter plot is moving in. So go ahead and pause this for the next 30 seconds and let everybody make sure that they have written down the line of best fit at the top of their notes. Alright, the next thing we are going to talk about is this little diagram on your notes. So on your notes, we have a diagram of a scatter plot. Now if you look at this scatter plot right here, you can see that there is a nice, very nice formation, and we have three separate individual lines. We have a green line, a purple line, and a red line. So let's go ahead and take a look at each one of these lines. So first thing I want to point out is that the scatter plot shows that the points plotted on here are moving in a positive direction or have a positive correlation. They are mostly going in an upward fashion to the right. Now, if I wanted to draw one line that showed the direction that these points were moving, I would need to pick a line that best fits them, or a line that best represents the relationship of my scatter plot. Now, how do I do that? There are a few things I want to pay attention to. So, in the middle, I have this purple line. And the reason the purple line is the line of best fit is because it goes pretty evenly throughout the data. The line of best fit, you want it to go through the middle of the data. Try to get at least 2 points on the line to fall on your line. So look, right here, you'll see that there's 1 point right here, and that there's another point right here, and that there's another point very close to the line right here, and then again it crosses through the line at this point, right? So I have at least 2 of my scatter plot points that are plotted against the line of best fit. And then I have a very even number of points above it and a very even number of points below it. I have about 3 points above it and I have about 3 points below it. Now the reason the green line doesn't work is it is too far above the data. So if we were looking here at the green line, we would see that there's 1 above it and then there's 1, 2, 3, 4, 5, 6 points below it. That's not an even distribution. Or if we look over here at the red line, we can see that there's just way too many points above the red line. Again, we like the purple line because it estimates about half of the data is above it and about half of the data is below it. So go ahead, you're going to want to make sure that you copy down on your sheet of paper that the line of best fit goes through the middle of the data, and you want to try to get at least 2 points on the line. You also want to copy down that the green line goes too far above most of the data, and that the red line goes too far below most of the data. Alright, now we are going to go ahead and look at these scatter plot diagrams that you do have in your notes. So let's go ahead and take a look. In your notes, you can see a scatter plot A, B, C, and D. Well, all of the scatter plots in these choices are exactly the same. However, it is your job to figure out which one has the line of best fit. So I want you to go ahead and pause the video now and give the students about 1 minute to go ahead and pick which one they think has the most accurate line of best fit for the scatter plot. So you're choosing between A, B, C, and D. And when you make your choice, I want you to think about the things that we just talked about. All right. Now that you've paused and let everybody choose exactly which scatter plot they think has the line of best fit, let's go ahead and talk about which is the correct answer. So, I want to start with a D. I'm going to move backwards. So D is not the right choice. Why is D not the right choice? Well, do you see this line right here? This line just goes like straight through the graph. It does not pay attention at all to what is happening here with the points on the scatter plot, right? Because if I look at these points are not a flat line. These points are moving in a positive upward direction. All right. Now, let's go ahead and take a look at C. So C is moving in a positive upward direction, and that is good. We do want our line of best fit to move in the same direction as our data. However, if we look at C, you can see that most of the points fall below the line of best fit, right? Most of the points plotted on your scatter plot fall below the line of best fit. That is not a good estimation of the line of best fit because, like we said earlier, we like things to be evenly distributed. Now, if I look over here at B, again, we have a problem. Most of the data falls above this line in plot B. So this is not an accurate line of best fit. Now, if we come up here to A, we can see that there's 1, 2, 3, 4, 5, 6, 7, 7 above, and that there's about 1, 2, 3, 4, 5, 6, 7, 8 points below the line of best fit. Now, there's about the same amount of points above the line of best fit as there are below the line of best fit. And it crosses through at least 2 points on my line. So, the line of best fit for this scatter plot was choice A. Again, let's take a closer look. So you have an equal number of points plotted above it and an equal number of points plotted below it. So I want you to now pause the video and let everybody copy down on the little area next to the diagram. I want you to go ahead and copy this down, that the best line for the line of best fit is A. I know that's a tricky sentence, but we're just going to go ahead and say the most accurate line of best fit is A. Why? Well, about half of the points fall above it and about half of the points fall below it. We are making sure that when we look at our line of best fit, we look and see how many points plotted on our scatter plot fall above and below, and when we estimate a line of best fit, we want to make sure that there is an equal number above and below. So go ahead and pause this for 30 seconds and let everyone copy down that. Okay. We now have a graph that shows the line of best fit that Jenny drew. So, before we move forward, I want you to go ahead and just take a look at this diagram. Okay? Before we even answer the question, I want you to take a look at the diagram. So here's the scatter plot. Now here are your points. Your points are going in a downward direction. That means that they must have a negative correlation. Negative correlation means that as your x increases, your y decreases. Now that is true for this scatter plot. And yes, this line of best fit is showing me that it decreases. However, this is not the way that we want to draw a line of best fit for this scatter plot. So, I want you to pause and think about what we have talked about. And I want you to explain to Jenny why her choice of line of best fit is not valid. When we say something is not valid, we mean it is not true. It is not correct. This is not the line of best fit for this data. So why is this not the line of best fit for this data? So go ahead and pause it and give the students 2 minutes to answer the question. And then we are going to go ahead and we are going to move forward and discuss the answer. So now is a good time to pause. Okay, this is not valid because the data does not fall evenly on both sides of the line of best fit. Now let's take a look at this again. So here's my line of best fit, and there's almost no data below it. There's only 1 point that falls below it, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 points that fall above it. That is not the way we want our line of best fit to be. We would like our line of best fit to cut directly through, right? We want it to fall evenly, half above, half below. Although this line of best fit does cross through 2 points on my scatter plot, which is good, it does not accurately represent the relationship between my x variable and my y variable. It does not accurately show the relationship between my x-axis and my y-axis because it does not accurately represent where half of the data falls. So half of the data falls above it and half of the data falls below your line of best fit. And this line of best fit has almost all of the data falling above it. All right, on your sheet of paper again, there is another example. In this next example, it shows you that there is a line of best fit that Albert drew. So here's your diagram right here. Hours and distance traveled. So your x-axis is the number of hours traveled, and your y-axis is the number of miles traveled. Okay, so we know that x is our independent variable, that as our x changes or gets greater, so does the amount of miles that we have traveled. The longer that we are in the car, the further we have gone. So we can see that this relationship is positive because each of the points on our scatter plot are moving in an upward direction. Now let's go ahead and take a look at this. This is almost a perfectly straight line. It's not perfectly straight, but we would definitely, when talking about a scatter plot, call this a strong positive correlation with a linear relationship. Why is it strong? Well, it's very clear that these are moving up. Why is it linear? Because almost a line could go almost perfectly through these points. So, what I need you to do now is let's go ahead and pause for another 2 minutes, and you are going to either agree or disagree as to why this is the line of best fit for this scatter plot. So Albert drew this line, and you are either going to agree with him or disagree with him, and I need you to defend your answer. So go ahead and pause the video for 2 minutes. Everybody should be writing. Okay, so let's go ahead and talk about this graph. So Albert drew this line. This is the line that Albert drew, and this is his points for his scatter plot. Do you agree or disagree? All right. Go ahead and take a second and raise your hand if you agreed. Put your hand down. Okay, everybody look around. Now go ahead and lift your hand and raise your hand if you disagreed. And everybody look around and see how many people agreed and how many people disagreed. All right. Well, I'm going to go ahead and I'm going to tell you the answer, which is you are going to disagree with Albert. Why? All of the data for this line falls below your line of best fit. You want your line of best fit to go exactly through as many points as possible on your scatter plot. This line of best fit doesn't go through any points, and every single point is below it. It does not go through as many points as possible, and it does not have as many points above it as it does below it. Okay, well, guess what else we know about linear relationships? We know slope. So guess what we are going to practice now? We are going to figure out how to find the slope of a scatter plot. So I'm going to go ahead and show you something real quick, but I need you to just pause, and we're going to have to stop this video and start a new one.